So here's the last part for our lesson on formalizing relations and functions. So this time, we will be finding the range of a function wherein the set of domain is given to us, the function rule is given to us, so we have to identify the range. Now, the nice thing about this is technically easy because all you need to do is replace your input value, your input variable by each of the domain values. Okay, so if your domain is so let's start with the first one. So if x is equal to 1, what will be the value of your y? Okay, what will be the range? So if this is f of 1, this will be negative 1.5 times 1 plus 4. Okay, so this will simply be negative 1.5 plus 4, and that is going to be positive 2.5. So the range when x is equal to 1, when your domain is 1, it is going to be equal to 2.5. Okay, if your x is the next number, so you have, if x is equal to 2, so you just replace the value of x by 2. So this is now negative 1.5 times 2 plus 4. Okay, negative 1.5 times 2 is going to be negative 3, and you add it to 4, and so f of 2 is going to be positive 1. Okay, so our range our range will be including 2.5. Okay, we have the value of 1. What is the next one? So if you have 3, so just replace x by 3. So you will have f of 3 is equal to negative 1.5 times 3 plus 4. This is going to be negative 4.5 plus 4, and so this is going to be negative 0.5. So you have your third range, which is negative 0.5, and then the last one, so if your x is equal to 4, that's your last domain, so f of 4 is going to be equal to negative 1.5 times 4, and then you add 4. This is going to be negative 6 plus 4, and so f of 4 is going to be negative 2. So that is your last range. So these numbers, these are the set of numbers that composes the range of f of x is equal to negative 1.5x plus 4. Okay, so easy peasy. All right, so why don't you try to find the range of this next function? We have g of x is equal to 4x minus 12, and our domain includes 1, 3, 5, and 7. So go ahead, try this one out. So if you substitute all your domain values to the function, to the variable x, you will get, if x is equal to 1, then your domain will be negative 8. If x is equal to 3, then your domain is 0. X is equal to 5, then your range is 8. If your domain is 7, then your range is negative 16. So our range will be negative 8, 0, 8, and 16. Okay? So this one, the last example, so sometimes there will be some scenarios wherein you will be asked for a reasonable domain. So this is where you have to identify if a discrete graph or a continuous graph would be better to show or to visualize the answer for this particular scenario. Okay, so in this problem, you have 3 quarts of paint to paint the trim in your house. So a quart of paint covers 100 feet squared. So the function a of q is equal to 100q simply represents the area in square feet that q quarts of paint can cover. Okay, so we have a few questions here. What domain and range are reasonable for the function? Okay, and what is the graph of the function? So we have our table of values here ready for us, and also our graphing. Okay, so what do we know from this problem? You are given 3 quarts of paint. So what is the minimum amount of paint that you can use? Well, you don't need to use anything, so that's 0 quarts. Okay, what is the maximum amount of paint that you can use? Well, you have a total of up to 3 quarts of paint. So that's the maximum value, okay? So since the quart of paint is our input variable here, then we know that our domain, okay, our domain could be equal to 0, okay, less than or equal, the domain will be greater than or equal to 0, and your domain will be less than or equal to 3. So any value that is between 0 and 3, that is our reasonable domain. Make sense? Okay, so now how do we know what is the reasonable range? So if we know that our domain, our x values is somewhere between 0 and 3, then we can plug it into our values here. So if we have 0, 1, 2, and 3 quarts, how much is the area that could be covered by each of the quarts of paint here? So 0, so remember our equation, A of Q is going to be 100 times Q. So imagine if your Q is 0, so 100 times 0, that's going to be a 0, okay? If you have 1 quart of paint, you can cover 100 square feet. If you have 2 quarts of paint, then you will be able to get 200 square feet. And if you have 3 quarts of paint, you will be able to cover an area of 300 square feet. Okay, so these numbers are your range. So here, our range is somewhere between 0 and what is the maximum range that we can have? 300. Okay, so these are our reasonable domain, reasonable range. So what is the graph of the function? So since we have ordered pairs here, we simply have to plot them. So we have a 0, 0, 1, 100, sorry, 1, 100 is here. 2, oops, sorry, that's 2, 200 up here. And then you have a 3, 300 over here. Now, the question is this graph continuous or discontinuous? So, if you use, so ask yourself, if you use, say, half quart of paint, will you be able to still get some area covered? Definitely. Okay. So since any value, any amount of paint here could cover a certain area, then this means that this is going to be a continuous graph. Okay, so that is how you can identify a reasonable domain. You have to always think of the context of the problem. Make sure you check what makes sense on the particular problem or situation that you are given. Okay, so to summarize our lesson, a function is a special type of relation in which each value in the domain, so our x value, is paired with only exactly one value of y, or our range. Thank you.